Hello everybody, welcome to the fifth semester Railway Engineering subject. The subject name is Railway and Bridge Engineering and we are studying the first part Railway Engineering in which we will see the permanent way components in which we will study the permanent way components, cross section of a permanent way, the railway, functions of various components, grip of rails and slipper density. So permanent, what is permanent way? So, a permanent way or a railway track can be defined as the combination of rails fitted on sleepers and resting on ballast and subgrade. So, what are the main components of a permanent way? Is first one is rail. Here we see on which the train wheels are rolling is called rails. Then sleepers. This is the sleeper. Fasteners fastening sleeper and rails, ballast, subgrade. So railway track or permanent way. As you are seeing in here, uh, first the ground portion is called subgrade. We are developing the subgrade on the ground, and above that we are putting the sub ballast. After the sub ballast, we are putting here the ballast bed. Okay. After ballast bed, we are fastening the sleepers. Here we see the sleepers. Okay. On sleeper, the rails are there. Here is one rail, and here is another rail. Okay. So these are the rails on which the wheel is rolling. The combination of rails fitted on sleepers and resting on ballast and subgrade is called a permanent way or railway track. Like different components as we have already seen in the slide number 1. uh, First one is rail, then there is a sleeper, there is ballast, sub ballast and subgrade. So first of all we will see what is the basic requirements, basic wantings of a good permanent way. So the gauge should be uniform and correct. Before that we must know the gauge. Gauge is the center to center distance between two rails. Both the rails should be at the same level in a straight track. On cars, proper super elevation should be provided to the outer rail. The permanent way should be properly designed so that the load of the train is uniformly distributed over the two rails. The track should have enough lateral strength. The radii and super elevation provided on curves should be properly designed. The track must have certain amount of elasticity. All joints, points and crossing should be properly designed. Drainage system of permanent way should be perfect. All the components of permanent way should be satisfy the design. It should have adequate provision for easy renewals and repair works. So these are all the permanent way, good permanent way requirement. First of all, we'll go for the first component of a permanent way, which is rails. Rails are the girders. huh? Rails are the continuous girders which carry the axial loads. They are made of high carbon steel because they require high strength to withstand wear and tear. Different types of rails as we here see. One is a double-headed rails, DH rails. Double-headed, this is one head and this is another head. So there are two heads, double-headed rails. Here it is, second one is bull-headed. The far head is big, that's why it is bull-headed rails. Then this is third one is flat-footed rails. The foot is flat. This one is flat-footed rails. So composition of rail steel is for ordinary rails. Carbon content is 55 to 68.55 to 0.68%. Manganese 0.65 to 0.9%. Silicon 0.05 to 0.3%. Sulfur 0.05% or below. Phosphorus also 0.06% below. For rails and points and crushing, carbon 0.5 to 0.6%, manganese 0.95 to 1.25%, silicon is 0.05 to 0.2%, sulfur is 0.06%, phosphorus is 0.06% or below. So, as we have seen, we have already discussed what is a gauge. Gauge or gauge is the distance between the inner area of two rails, and it's called a gauge. The clear minimum horizontal distance between the inner face of two rails, inner face of two rails forming a track is known as gauge. Indian Railway followed this practice. In European countries, the gauge is measured between inner face of two rails at a point 14 millimeter below the top of the rail. Okay, so there are so many types of gauges: standard gauge, broad gauge, broad gauge 2, Cape gauge, meter gauge, and 23 other various gauges are in India. We are basically uh, uh, following three gauges: broad gauge, meter gauge, and narrow gauge. The width of broad gauge is the highest, which is 1.676 meter, and in meter gauge it is 1 meter as the name says, and narrow gauge is 762 millimeter, 0.762 meter. So percentage covered in our country, broad gauge we are maximum using broad gauge, then 31% in as meter gauge and just 6% as narrow gauge. So different length of rails we are using our Indian Railway. Broad gauge we nearly are getting 13-meter length of rail. In meter gauge we are getting 12-meter rail gauges. In meter gauge rail lengths. It is proposed to increase the length economically up to 25.6 meter or 19.2 meter per broad gauge track. In countries like USA and UK, etc., they are using 30 meter for speed construction, for better joint free construction. We are also planning, or we are nowadays getting bigger length rails. So suitability of different gauges. Why there are different gauges? What is the need? What is the suitability? Broad gauge, when sufficient funds are available, broad gauge is a costly affair. Sufficient funds are available for the railway project when the prospect of revenue are very bright. So where the revenue is coming in a good way, we are putting there the broad gauge. Meter gauge, when the funds are available in a tight manner and the revenue is not so good. Narrow gauge, when the construction of a track with wider gauge is impossible. Sharp curves needed, stiff gradients are there, narrow bridges are there. and revenue also not very bright. So there we use um, narrow gauges. So choice of a gauge depends upon these factors. First one is definitely the investment cost. We are considering the cost first. Then the second one is the traffic consideration. How much volume of the traffic will be benefited from that um, gauge uh, distinction. Physical features of the country terrains are there, plains are there. So physical features of the country in high terrains we are in broad gauges it is not possible. We will go for narrow gauges. Uniformity of gauges, we must get better area to have the proper gauge speed of the train. uh, it is also a fundamental choice. Then the second component is sleepers. The main function of sleepers is to hold the rails on it. To hold the rails on it, giving uh, a firm and even support to the rails, transferring the load evenly from the rails to a wider area of the ballast, acting as an elastic medium between the rails and the ballast to absorb the blows and vibrations of the moving loads on it. It transfers the wheel loads to the ballast by giving an elastic in between, providing longitudinal and lateral stability to the permanent wave, providing uh, means to rectify the track geometry. So the third component is the ballast, rail, slipper, and third one is the ballast. So ballast, these force aggregates of nearly 40 millimeter and above size, which we are putting here. Hmm. These are called ballast. So types of ballast there are broken stone, gravel, coarse sand, concrete, brick bats, selected arch. Hmm. So you can see this figure. Uh, this is your ballast area. Hmm. These are the ballast on which the slipper is there and the rail is there. Okay, and the ballast are on the subgrade, on the subgrade. Okay, so how the ballast, slipper, and then the chair and rail like this. So some other components like fish plates. You see, while two rails are we are joining, we are providing fish plates. As you see here, we are providing fish plates. This one is a fish plate to give proper joint. So in this figure, you can see all 4 5 components like this one is the ballast, this is the wooden sleeper, then this is the fastener, and this is slipper, and these are the rails. Okay, so in fastener like fish plates, these are also other fasteners we are using in railways. So we can discuss creep here. The creep can be defined as the longitudinal movement of rails in a track. Creep is a location specific. We may not found a creep, that is the longitudinal movement of the rails happening along whole of the length of the railway track. It is mostly being found only at a certain specific location. Here you see this figure. So because of creep, the magnitude of creep at one point is not necessarily the same at the other point. So there are creep indicators, joints, closing of joints in the direction of creep, opening of joints at the point where the creep starts, scraping or scratching marks on the rail fringes or the waves due to spike head. So what are the main causes of creep? As you are seeing here, main causes of creep. Uh, Ironing effect of the wheel. The ironing effect of moving wheels on the waves formed in the rail tends to cause the rail to move in the direction of traffic and resulting in creep. Starting and stopping operations. When the train starts and accelerates, backward thrust of the wheel tends to push the rail backward. Similarly, when the train slows down, comes to a halt, the effect of applied brakes tends to push the rail forward. This turn causes creep in one direction, uh, either forward or either backward. The third one is change in temperature. The temperature due to temperature variation, there is expansion contraction of the railway. So what are the main effects of creep? Opening or jamming of joints. Joint will be more open or will be jammed. Kink formation at joints. Slippers get out of the position. It affects gauge and elements. Bucking of trains. It can derail the train also. Point crossing switches, interlocking gates distorted due to this grip. So we are referring these books, and thank you all for your patient listening. Thank you so much.